Hi everyone. I wanted to give a little bit more information on a topic from this week, and that topic is hydrogen bonds. Hydrogen bonds are very important and they're going to come back as a topic throughout the semester. So what we see here are a number of water molecules. The red circles are oxygen atoms, and then the white circles are hydrogen atoms. You can see that this is one singular water molecule that I'm highlighting here, and that water molecule consists of an oxygen and two hydrogens, and the oxygen is sharing electrons with the hydrogens, and the hydrogens are sharing electrons with the oxygen. In this one bond that I'm highlighting right here, the oxygen is sharing an electron with this hydrogen, and the hydrogen is sharing an electron with the oxygen. That forms this covalent bond, which is depicted as this solid line. Then we have the same thing going on here with this other hydrogen. Interestingly, the oxygen is an element that has high electronegativity, which means that it's really good at pulling electrons towards the nucleus of the atom. Hydrogens are very small, and smaller elements tend to have lower electronegativity, so hydrogen has very low electronegativity, so it's not so good at pulling electrons toward itself. So these electrons that are in this covalent bond that are shared, they are not shared equally. Just as sharing in our human lives is not always equal, sharing of electrons in covalent bonds doesn't always need to be equal, especially if the covalent bond is between two different elements. Here we have oxygen, which is highly electronegative, hydrogen, which is not very electronegative at all, and so the electrons in that shared bond are pulled closer to the oxygen. And so this oxygen, therefore, has what we call a partial negative charge. And we call that a dipole in the molecule. So the oxygen has a partial negative charge, the hydrogen has a partial positive charge. Again, because there's not a full transfer of electrons as you would have in an ionic bond, but there is an unequal sharing of the electrons in the covalent bond. Because we have a partial negative charge and a partial positive charge, then we can have these atoms interact with other molecules that might also have partial charges. And so when you have a solution of water molecules like this, you have tons of partial positive and partial negative charges. This is how water molecules interact with one another. All of the oxygens that have partial negative charges are going to be forming hydrogen bonds with the hydrogens that have partial positive charges. So again, the hydrogen bond here is represented by these green they look like radar lines or sonar lines or something. This is the hydrogen bond. Hydrogen bonds are technically not bonds in the chemistry sense, they're interactions. Because it is not quite an ionic bond, but it's also not shared electrons. We saw a covalent bond here and here, but this is different. This is an interaction between two water molecules where the partial negative charge on the oxygen interacts with the partial positive charge on the hydrogen. So of course, as always, opposite charges attract. It's not a full charge, it's a partial charge where there's a weak attraction between this partial negative charge and a partial positive charge. And as we see, that's happening between all the different water molecules in solution. But because these are weak interactions, because they are partial charges, it means that these can be broken very easily, at least when the solution is liquid, or in the instance of gas. So in liquid water, these interactions, these hydrogen bonds, are constantly being broken and formed with new water molecules. However, when we freeze this, then the water molecules are no longer able to interact, they're no longer able to break those bonds. When they can't break those hydrogen bonds, then they have to stay in the exact orientation that they are at this moment. So if this were liquid, then maybe you would break this bond right here, this hydrogen bond, and maybe this hydrogen would be able to get a little bit closer to this oxygen, or maybe it would even get a little bit closer to this hydrogen, just momentarily until it started to interact with another oxygen. Maybe you would start interacting with this oxygen. And so those molecules, those water molecules, could get closer together momentarily, at least some of them. When this is ice, instead, the hydrogen bonds are frozen in place and all the water is pretty much spaced out. That's why ice has a lower density than liquid water, and that's only water ice has a lower density. It's less dense because the molecules are spread out because of these hydrogen bonds, these hydrogen interactions. When you have liquid water, then again, you could have these hydrogen bonds breaking and then forming with different water molecules. So water molecules could get closer and then maybe a little bit further. But overall, the solution is more dense. Now, that's not true of many solutions, or most solutions even, because most molecules are not able to form hydrogen bonds. Now, one last thing that I wanted to bring up here is that water's not the only molecule that forms hydrogen bonds. And so I put an image of DNA here, and DNA has hydrogen bonds as well. The hydrogen bonds in DNA are between two strands of DNA. So this is a double helix of DNA, and we don't see the hydrogen bonds depicted here, but if we look really closely and we see that this is the backbone of the DNA, and we'll get into this in more detail in the future, but I just want to note it here. We see that these dotted lines, they're pink this time, but again, they look kind of like dashed lines or like a sonar depiction. They are hydrogen bonds between the bases. And so the base pairs, the T and the A and the C and the G, they are interacting through these hydrogen bonds. And we're not seeing it here, but that is because we have one atom that is electronegative and one atom that is really not electronegative or has very weak electronegativity, which is causing a dipole and a partial charge interaction with another partial charge. And again, we'll go into this and we'll look at the exact chemical structures later in the semester, but this is just another example of how hydrogen bonds are really important and are going to come back over and over again throughout our course.